All right.
Okay.
Baruch, take it away.
Yep. All right. We're going to talk about DevOps patterns and anti-patterns for continuous updates. And we're going to talk a lot about what could possibly go wrong if you want to update your software. I mean, how hard can it be? Before we start, let's understand why we update software in the first place. Obviously, there is some software that doesn't require any updates. You probably heard about BC or used it maybe. It's a command line calculator. And what I'm surprised about it was it got updated like every year between 1997 and 2000. It wasn't updated since then for 20 years. Well, for a good reason, right? The command line didn't change much. The rules of math didn't change much. Why bother? But this is obviously an exception. Most of the software updated very frequently, and the later, the more frequent. And there are two main reasons for that. The first one is us. And by us, I mean everybody, all of us are users and consumers of software. And to understand how that progressed from not so distant past to now, we can think about our phones. So if you are as old as I am, you might remember your dummy phone in the 90s. You had Nokia and it might have Snake. And if it didn't have Snake, what did you do? You bought a new phone, or you just go ahead without Snake. And then when you bought a new phone and you want to install the Snake on it, you obviously couldn't. There was this data cable, if you remember, you could buy it separately, and then you can possibly maybe update your phone. Not really. You could download the contacts and then upload them back in a new phone with the Snake. But obviously everything changed in 2007 with the introduction of iPhone, of smartphones, and now we live on software updates. We want our applications, our games, our operating system, our features get updated as fast as possible. And most of the time you don't even care to check, to expect, it just happens. It lives in your pocket and it's get updated. Awesome. Another very important reason for software updates are security vulnerabilities.
And that's where I step in. So old software is really, really, really dangerous. It could be compared to the digital version of an oil spill in some of these examples. It's really, really destructive, and it's not an immediate fix. So we have to deal with the time it takes to identify that a problem even exists, the time it takes to actually fix it, which could just be updating your dependencies, and then the time it takes to deploy the update. And this is where continuous updates become a big deal, because the faster you can update, the better off you are. So let me look at a couple of examples for you. You might remember about 3-ish years ago, maybe 4 now, there was an exploit that effectively shut down entire hospital systems in the UK after ransomware took over their networks. It was identified immediately, which is really, really great, but the fix was upgrading the operating systems. These hospitals were also using Windows XP, which had reached end of life and was not being supported with security updates anymore. Obviously, we can't expect Microsoft to support an operating system for eternity, even if it is like really commonly used by hospitals and government systems. The ransomware was able to take advantage of an unpatched security flaw and take over. It took them literally years to deploy the fix in this case. They had to upgrade every system in every hospital all the way from Windows XP to current year. Another example you definitely remember is the Equifax debacle. In September of 2017, Equifax announced that a serious breach had occurred. It happened between May and July of that year. The first month is important, May. The names, addresses, birth dates, driver's license numbers, and social security numbers of just shy of 149 million Americans, plus a bunch of people from Canada and the UK, had been stolen. The hackers had exploited CVE 2017-5638, a vulnerability in a very commonly used web framework called Apache Struts. Talking about like how that vulnerability actually works is out of scope here, but the gist is that it allowed an attacker to remotely execute commands with whatever authority the web server had. Now, this was not a vulnerability that flew under the radar. Even before the Equifax breach, this vulnerability was like big news in the security world. It wasn't subtle at all. It was classed as a critical vulnerability, something with a CVSS score of like 10. It absolutely had to be taken seriously. It had to be corrected immediately. You were not supposed to mess around with this. The vulnerability was disclosed and published in March, months before Equifax was actually breached. Once they discovered the problem, it took them 2 whole months past that point to find and upgrade all usages of the vulnerable version of Struts. The attackers had remained in their system completely undetected for 134 days. Kind of ridiculous. Now, I know that we've only really talked about vulnerabilities in like big enterprise environments that are kind of going to be slower to update just by their very nature. And you're probably saying to yourself, well, in our environment, because we're a lean, hip, young startup, this isn't a problem. We know how to update immediately. So this could never happen to us. That's cool and all, but it's actually not enough. Spectre and Meltdown went public a little more than a year ago, and people mostly talked about Meltdown because like 10 lines of JavaScript could expose passwords from different parts of memory, and that's real bad, right? It's terrifying, but I think Spectre is the more dangerous of the two. The problem with Spectre is that while most malware exploits coding errors or like bad design, Spectre exploits good design. Its attack works by observing how well-designed applications affect the memory and what decisions the CPU makes based on certain conditions in the code. From there, it assumes that other software reasoning the same way will lead to the same decisions. So the better your code is written, the more vulnerable it is to Spectre class attacks. So what are you going to do? Are you going to write bad code just to confuse speculative execution? That's absurd. So what then? You have to recognize, okay, this code is vulnerable, and now you have to race the attacker. We have to identify the problem as fast as possible. We need to fix the problem as fast as possible. And we need to deploy the fixes as fast as possible. Updating rapidly is what this talk is about. Baruch, take it away.
Yeah, that's very true, and that this is what this talk is about, and this is why it's important. But we can check where we stand now. And as usual, when we need to check where we stand in our DevOps world, we go to the State of DevOps report to look what's going on. And what we see in State of DevOps report is that everything is not horrible. You can see, you know about DevOps report, it's like super serious survey, 31,000 organizations, and you see that already 20% of it doing very good. They call the lead performance for a good reason. They call the lead performance because they can update the software wherever, whenever they want, right? It's called on-demand updates, and you can do it whenever you want. And it's basically that. This is DevOps. And the reason why we have every 5th organization in the world doing it, it's because it's not a new idea. It's not a new idea because it's been around for more than 20 years. 1998, Extreme Programming was advocating for short feedback. And then 2000, Agile, reducing Scrum, reducing cycle time to absolute minimum. And then other methodologies like Toyota Production System or Lean Manufacturing, and then Kanban. every methodology that we live by today and we take it for granted actually advocates for shorter feedback, faster release cycles. So it's 22 years, but still here we are. Let's talk about what can possibly go wrong.
And now we'll finally actually introduce ourselves so you know who we are. Baruch likes the hook at the beginning. So my name is Kat Cosgrove, and I'm a developer advocate at JFrog. Before that, I was actually an engineer on the IoT team here. If you would like to get a hold of me, I am on Twitter at Dixie3Flatline. You can try sending me an email, but I will warn you that I don't do the zero inbox thing. So like Twitter genuinely might be faster. Our slides will be up after the conference is over at jfrog.com/show notes with like links to some resources and whatnot. And now I will let Baruch introduce himself.
Yeah, and thank you, Kat. My name is Baruch Sadogurski. I'm the Chief Sticker Officer. If it was an in-person event, would probably bring tons of stickers for all of you. But meanwhile, we'll have to do with what? Stickers on, where do you have stickers? WhatsApp or something? Probably Slack as well. I am also head of DevOps advocacy with JFrog, and that's the hat I have in now. At JBaruch is the most important part of this slide. But JFrog, I hope you're all familiar. We do software for faster updates, among other things. So if you are convinced that you need to update faster, thanks to this talk, maybe check our software out as well. The most important slide of this entire presentation is the next one. Yes. So the most important slide is you want to go faster. And you want to go faster because all the reasons that we mentioned. And let's see how it works. And we will examine one example in question, Java. I don't need to explain what it is. Mark, I hope, Mark Reynolds, head of Java platform, one of the two most important people in Java world, declared 3 years ago, that Java, more than 3 years ago, the Java is going to update faster. Back then, it was Java 8 that was out, and Mark declared that they're going to update every 6 months. For the exact reasons that we mentioned. They want to push features faster to the users, and they want to make sure they cover all the security concerns as fast as possible, and they want to know that they're able to release faster when they need to. So 3 years ago, Java 8 was the version. Since then, they released Java 9, Java 10, Java 11, Java 12, Java 13, Java 14, and Java 15 a couple of weeks ago. That makes it 7 versions. And then we look at production servers, not we. That's New Relic, looking at production servers across the world. And what they discover, more than 80% of the industry is still on Java 8. Yes, the same Java 8 that was out there where Mark announced that they're going to release faster. So this didn't work very well. The reason really is why. Kat, can you walk us through why that happened?
Sure can, or at least I can try. So why are there still so many people on Java 8? To understand what happens, we need to understand why and how we actually update, like as users. So this is how users decide to update. Something new.
I'm sorry that this diagram goes right to left. I created it and then my Israeli roots took over. So it's kind of a little bit in Hebrew. So I apologize for that.
It's fine. It's fine. It's transitions. They can still get it. So like something new is released, there's a new version, and the user has a decision to make. Do I actually want this? If there's nothing interesting in it, we say no, and we move along with our previous version. If it's yes, we have to ask another question. Are there any risks? This is an easy question with things that don't matter, like the Netflix app on your smart TV, or like Candy Crush on your phone, or whatever app phone game people play these days. If there are risks, we don't say no immediately. We ask if we trust the update. That one is harder because there aren't really a lot of companies or vendors that we just blindly trust. In the early 2010s, though, and a little bit before that, we did tend to blindly trust Apple. So we'll use them as an example. If there was an update for Mac OS back then, you probably just went for it, even though that absolutely should be considered a high risk update. It's your entire operating system. This isn't as true now. Personally, I will wait months or longer to update Mac OS. I skipped High Sierra entirely. So what happened? Why don't we trust our vendors anymore? Did they forget how to do QA? We tend to get better at the things we do, so I don't know if that's really the right answer. The data is actually a huge problem. We have so much of it. This is a prediction of the global data sphere by 2025, and this data does come from Seagate, who definitely has a dog in this race. So, you know, take it with a grain of salt, but it's a lot. Today we think of petabytes as large, but we're rapidly moving into the realm of exabytes and zettabytes. It's already mind-boggling, and by 2025, it is an absolutely nuts 175 zettabytes. What this means is that staging environments have to die. It does not make economic sense to replicate your production environment for staging. Big companies are already testing in prod. Get used to it. Just test in production. So data is a major contributor to the issue of guaranteeing quality. What do we do about it? We have another question in our decision tree now. Can we verify that the update is going to be worth the work involved? If we can't, we just don't update. We skip the version. If we can, we have to spend time going through time-consuming user acceptance testing and verification. This is a problem for us as software providers because users don't want to do all of this. So we have to make sure that every update includes so many appealing features that they'll be willing to just deal with it. Baruch, is this yours?
I insist on this slide.
Oh, have it.
Yeah, it's very Russian, so I couldn't skip it. Well, basically the idea is in order for update to be lucrative, you need to put a lot of food on the table.
Okay, I love it. I love it. That's cute. So we have to strike a balance here. Features that we want versus the cost of actually accepting the update. And it's not that easy. It's a vicious cycle. Vendors pack in more features, so the update is more expensive or difficult or time consuming to test. And then the users defer the update because it seems like a pain. So vendors pack in more features and it just gets like worse and worse and worse. So how do we get around that? Is there a cheat code? Does the Konami code work here? I wish it did. It does not. There's not, you can't just like treat it like a 90s, 80s video game. But we can get close with auto updates. This only works for things that aren't high risk, like your web browser or the Twitter app on your phone. I bet most of you have no idea what version Chrome is right now, or Firefox, or whatever your web browser is. These are low risk updates, so they just happen without notifying you. Maybe you have to reboot your browser, but that's it. By contrast, your smartphone's OS is a high risk update. You probably do know what version of Android you're running. This update requires human intervention. So we end up back at the previous decision of, are the features worth the risk of updating?
All right. So with this information, let's get to the fun part of this talk, and that's horror stories. Let's talk about what could possibly go wrong. And let's start with a personal one, and I love this one. It's touching. But you know that Google are in the game of Wi-Fi routers for a while, and the OnHub, their first, was released, I think, something like 2015 or something. And I was very, very excited to get one because it promised a self-improving system. A self-improving system means over there updates, and that mostly got me excited because of the features, although I understand that routers are also very vulnerable to different exploits. And since they don't have like UI that you can see a warning that there is a problem, you will never update them. Otherwise, they just provide you the internet. So I went with that. I was extremely happy. And then it's 3.5 now years ago, I was on some conference speaking. You remember in person when you kind of get on the plane and you fly somewhere, and then there are people there, like actually other people who are not your family, and you hang out with them. It was amazing. And I was in this conference, and then my wife calls me, and he's like, Baruch, there is a problem. I came back from work, and kids are sitting in the dark. And I'm like, what's going on? Is there like a power outage? And she's like, no, the power is fine, but the internet doesn't work. And the kids keep shouting, Alexa, turn on the lights. Alexa could turn on the lights, and nothing happened. So this day, the kids learn that there is a physical switch on the wall that they can defer to if there is no internet. But we went to investigate what's going on with the internet, and we couldn't find anything because our provider claims that it's fine. We restart the router, nothing changes. And then I got this email, and this email is, oops, sorry, we pushed an update to your router and we accidentally reset it to factory settings. And now there is nothing we can do because we cannot reach the router, so we cannot fix it. And now it's up to you to go and manually reconnect it to the network and reconfigure it again. I mean, you do need the internet to get email. Yeah, but well, I mean, that was not a big deal, right? Because in the end of the day, it was just a router at home. It's in reach. I can go there. I can reconfigure. But think about other scenarios in which this can happen. Think about a solar panels array somewhere in the desert when you need 3 days to get there, and something like this happens. This is big losses. Sometimes the update goes catastrophically wrong and you cannot achieve the device anymore. And what you need in order to fix it is local rollback. And local rollback means that the system will check itself after the update. And if something doesn't work, if a router cannot connect to the internet anymore, we will revert back to the previous version to ensure that everything works. Now, the mind-blowing thing is that it's not a new concept. If you remember Windows, I couldn't find a screenshot for Windows 95, so I used a screenshot for Windows 98, but that's exactly the idea. When you connected new video graphics card or you change the resolution of your screen, that was the screen that you saw. This is local rollback. If the screen is dark, and that means that you cannot okay the change, it will revert back to the previous settings to ensure that you can use your computer. By now, everybody just forgot how this is done, and this is ridiculous. Now, you can say, well, yes, but this example, it's an IoT, it's a router, it's not what we do here. We update servers, clusters, Kubernetes, serverless, what's not. Why are you even bothering telling us that? But we would claim that the T in IoT, the things, means everything. Your server or your cloud or whatever you are updating is a thing as much as any other thing. And when we are talking about things which are fun to update, let's talk about another one. How about updating a car?
Alrighty. I know some of y'all might not want to think of cars as IoT devices, and every time I give a talk about updating a car, at some point, somebody will say, no, I drive a 2001 Acura. It doesn't have any computers in it. I am so sorry, but it's like full of them. It's like full of them. The brakes have been computerized since the early 90s. And it turns out we're not great at updating them. The Jaguar I-Pace is a very beautiful and also very expensive car. Most cars, electric or not, do have multiple computers in them, lots of them. In 2019, a software problem with the braking system was found to be the cause of a regenerative braking system failure. However, Jaguars and most cars, actually, Tesla is really the exception here, cannot update over the air at all. So they had to issue a widespread recall for this car. Something like 15% of vehicle recalls are the result of bad software. And physical recalls are really expensive. You have the PR cost of issuing one to begin with, but then you have actual cost in real money to rectify the issue. Even bigger problem, you can't actually force the user to upgrade. They have to make the decision to take the car into a service center, probably take the whole day off of work and wait for their car. It sucks. And the solution here is to implement over-the-air updates. Like, that's it. Just over-the-air updates, preferably continuous updates. So what's the difference between over-the-air updates and continuous over-the-air updates? Baruch,
Yep.
tell me about
And
another example.
you mentioned Tesla, and that's like the shiny example of continuous software software updates that we know. And Tesla is a great car, but it's software, so it has some bugs. One of the more annoying bugs is called phantom braking, and that's where the car is driving on autopilot and slams on brakes out of nowhere. This is very annoying, not only because it's just unpleasant, because try to explain to your family that was you in the car that it wasn't you who slammed the brake out of the reason, it was actually a car. Anyway, big deal in the Tesla community. People are constantly complaining, and there was a rumor that there is a fix for phantom braking, and people were waiting and waiting and waiting on a fix, and the fix never came. And then people realized what took that so long. It was chess. The same update that has these small improvements and bug fixes that allegedly fix the phantom braking also had the major feature of chess. And that's important because that's what you allegedly play when you wait on on a supercharger for your car to park. And then people are like, what? I suffer from phantom braking and I waited for chess. How ridiculous that is. Why my important feature wait for less important feature? But there are other type of people, and those people are smart. They play chess and they do not use early access autopilot. So they really don't care about phantom braking, but they do care about chess a lot. And those people were outraged as well because they waited long for chess in order for someone to fix some bug in the feature they don't use. The problem is that when you do updates in batches, important features wait for non-important features, regardless of what is important for you or other user. We have preferences, and the way to go around it is just don't wait. Implement what we call continuous updates. When you have a bug fix, ship it. When you have a release, ship it. Just constantly ship it frequently and often, and this is continuous updates. And you might say, you know what, enough with this IoT bullshit. I'm not an IoT developer. Their lives are different, and we are much in a better place. We're better developers. I don't know. Well, the thing is, that's not the case. Their life is much more miserable because we are server-side developers, let's call it that way, that update targets which are within our control have a much better life. We control the availability of the target. We control the state of the target. We control the version that we update from and to on the target. And we generally have physical access. We can go and fix something went wrong, or we can open a ticket that the support of our vendor will go and fix it for us. None of that is true for IoT and automotive and edge devices. So our life is easier, and still we manage to screw up royally.
Boy, do we ever. Submitted for the approval of DevOps Days Buffalo, as if this is an episode of a 90s Nickelodeon children's horror show. In 2012, a bad software update caused a major stock market disruption and tanked the value of a company called Knight Capital. A lot of you may have heard this before, but it's outrageous and it's impactful. Even though it's old, we can absolutely still learn from this because we are still making these mistakes. So they were a trading firm that specialized in automated transactions on the New York Stock Exchange. And one day, it all came crashing down. You see, they weren't automating their updates or their deployments, and they weren't really updating all that frequently either. Remember, humans are really bad at repetitive tasks. We are especially bad at repetitive tasks when we don't get a lot of practice at those things anyway. Two problems contributed to the disaster to come. When the engineer was updating the 8 servers responsible for handling these automated trades, he forgot one. Only 7 of the 8 had the new software. They also reused an API endpoint and changed the behavior in the new version. So you can probably see where this is headed. Requests to the old server running the old API endpoint wreaked havoc on the share prices of 148 companies. Engineers responded by taking the 7 updated machines offline to roll back the software, increasing the load on the one machine that was never updated to begin with. There was no logging, no monitoring, and no alerts. They had to sit there, desperately trying to figure out what had happened, losing money minute over minute. In the 45 minutes this bad update was live, Knight Capital lost $440 million and ultimately went out of business as a result. Tragic and preventable. Those softwares were all being updated manually, but humans get tired or bored or distracted, and we're just not working at 100%, and these mistakes happen. It happens. It's normal. It's not something that we should judge people for. You know, we're not perfect, but you know what is perfect? Computers, at least if they're, you know, well trained. So the solution here is to automate the deployments. It's as simple as that, and you'll see that as the answer to a lot of problems here. Just automate it all, because computers don't get tired, and they also weren't updating frequently. Not deploying regularly makes every infrequent update way more stressful, which people don't handle well. And the answer here is to update more frequently, develop skill and habit, hopefully automate most of that update process. If you're used to it, you're not going to be anxious about it, and you're not going to potentially make a mistake like forgetting to update one machine. Another problem is that they reuse some state on the target machine. This could be a good decision or a bad decision. It depends, but regardless, you need to know the state of the target when updating. Reverting an update might require reverting the state too, you know? So you have to know what will happen. You cannot go in blind. This one is for Baruch.
Yes. So Cloudflare, that's the episode from last year. It actually happened on July 3rd, and got 30 minutes break from the internet for all of us. Let's dig into what happened. So one of the jobs of Cloudflare is fighting DDoS and other type of internet attacks. So what they do is they deploy routing rules constantly, and they change them constantly to kind of battle those attacks. And on this glory day, they deployed one errorless rule. And obviously, you know what, you can guess what the error was. And this is something, by the way, that convinces me that the Earth won't die of a nuclear all-destructing war or a pandemic or even a thermal death. It will die from a misconfigured regular expression. That what happened with Cloudflare. Someone misconfigured a regular expression, made the CPU spike to 100%, and then all the rest of the CPU spiked on 100%. And the next thing you see on their status page is affected region Earth, which was very, very correct. And they fixed it pretty quick, and the postmortem was, as usual, awesome. This is how we learn about it, but there are some things to learn. And the first is progressive delivery. Progressive delivery is very simple idea that if you deploy something erroneous to all of those users, all of them suffer. So instead of deploying to everybody, let's deploy to a part of them and see what's happening. And if there is a problem, the blast radius, and I love the term blast radius, will be reduced to a portion of users that will suffer, and then we can stop the release or update the affected users. Now, as I already mentioned, a lot of those techniques are with us for forever. And progressive delivery, you probably learned when you were like 8 years old. When your parents teach you how to do laundry, you remember all the detergent and the fabric treateners have this warning: try on some hidden spot first, and then observe if the fabric is okay, and only then apply to the entire garment. That's exactly the idea. That's progressive delivery. Progressive delivery worth nothing without observability, because you need to know that something went wrong. You need to learn, when you look at this fabric, you need to see that there is a stain. So you have to implement observability, because otherwise you rely on complaints on Twitter, which is fun, but a little bit less productive. It's hard to troubleshoot based on complaints on Twitter. So instead, you implement observability with all three pillars of it, which is tracing, monitoring, and logging. We're on DevOps Days. We will have talks about observability, so please go ahead and learn about that. Obviously, rollbacks. When things go bad, now instead of waiting for the fix, you can just go ahead and roll back to the previous version. And there are a lot of techniques that allow rollbacks, and a lot of problems that allow rollbacks, but some of them don't. And if you have a platform that do not allow rollback, for example, the mobile platforms, both Google Play Store and App Store, Apple App Store don't support rollbacks. If you want to roll back, if you made a mistake and you release the bad version, what do? Well, you take the previous binary, you rename it as the next binary, and you submit it to review. And then it takes what it takes, 1 day, 3 days, depending, weekend, load, etc., until it actually gets to production. And all this time, all of your users are suffering because you cannot roll back. What you can do to go around it is implement feature flags. And feature flags are programmable way to control which features are available. So before you make this feature available for everybody, in your progressive delivery, you start small, you enable it to a small group of people, and then using API from your backend, you can control whether you want to make it available for more people, or the other way around, roll it back and hide it from everybody.
And then Cloudflare struck again. Almost exactly 1 year later, it happened again. I swear we're going to get to a point where I can write a whole conference talk just about Cloudflare outages. It's like, it's stressing me out. So while performing maintenance on one segment, engineers wanted to route that traffic through Atlanta, take the traffic that was supposed to be going Newark to Chicago and route it through Atlanta instead. However, they were once again updating a config file manually. and they accidentally routed all of the traffic through Atlanta instead. So obviously Atlanta crashed, which caused a chain reaction, and we once again saw an affected region of Earth from Cloudflare. Y'all, Cloudflare, thank you. Thank you for the content. So once again, we are really bad at repetitive tasks. Like, I think we've said, please automate it like 17 times in this talk. It's always the problem. So why are we not? Please do it.
So just to summarize what we learned, continuous updates are frequent, right? We spoke about that. Are automatic. We spoke about that. Are tested as much as possible. We spoke about how it's impossible to achieve progressively delivered because it's impossible to achieve 100% staging, testing, state aware, and can be rolled back and observable and locally rolled back. That's kind of an extra credit task, but when you need it, you need it. And the goal with the entire thing of Liquid software is to get to the state when we have an update available, it doesn't matter if we want it or not, because it will be installed anyway. It's continuous updates. And obviously, if there are no high risks, there are no question. But even if there are risks, we got to the state in which we trust our software. And that means that we can update always and have the continuous update implemented anyway. So our goal is to transition from bulk and rare software updates to extremely tiny and extremely frequent software updates. So tiny and so frequent that they provide an illusion of software flowing from the development to the update target. We call this vision Liquid software. And I had the honor to co-author with two of co-founders of JFrog a book called Liquid Software about continuous updates. And for thanking you for coming to our talk and this great conference, I will be happy to ship this book to each and every one of you if you ping me on Twitter, LinkedIn, email, or whatever. Just send me your shipping address. I will ship you the book as a thank you for being here. And there are some corner cases in which you think continuous updates are a horrible idea. For example, a medical equipment doing a medical surgery, you probably won't want to update them on the flight, but they are actually rarer than you'd expect. And Kat, I want to ask you something. So do you think updating a plane mid-flight is a good idea?
Probably not.
No, you don't? All right, so here's a story for you. Airbus A350 has a memory leak. It has to be restarted every 150 hours. You can say, well, I will not fly an Airbus A350 from now on, but it looks like it's an industry problem because Boeing 787, an amazing plane, the Dreamliner, has a registry leak and has to be rebooted every 51 days. So if you limit yourself only to the planes that don't need to be updated because their software is perfect, you will probably stay on the ground most of the time. Now let's take a situation in which you are, you fly from Seattle to Tokyo and you are mid-Pacific, you passed Hawaii, there is no land in sight, and then the co-pilot asks the pilot, hey, did you remember to reboot the plane this morning? And then the co-pilot goes like, oops, I think I forgot. What are you gonna do? Wouldn't it be nice that the plane would be updated? Vijay, what do you say? You're on mute.
What do I say? I say update it mid-flight. Let's see what happens.
Exactly.
YOLO.
And I love the attitude. And the good news for both of us is that it's not as dangerous as it seems. It has been done before. In the great book From Project to Product, you can see a story about how the predecessor of the Dreamliner, the 777, was actually updated mid-flight. They had a problem with turbulence stabilization, and they couldn't fix it on Earth, on the ground. So they took all the software engineers, boarded them, took off, went to the place where there was turbulence, debugged it, patched it, and verified that it works all in the air during mid-flight. And it actually worked. And now 777 is one of the best planes in the industry. And here we go, updated mid-flight, software updates can work even mid-flight. With that, thank you very much. Couple of useful links and mentions. Kat is Dixie3 Frontline on Twitter, and she promises prizes to whoever knows what this refers to. I'm at jbaruch on Twitter. DM me for the book. This is DevOps Days Buffalo. I think I screwed up the hashtag, but PG will correct me in a sec what is the right hashtag. And liquidsoftware.com is where you can learn more about the Liquid Software vision. Don't forget the jeffrey.com show notes. The slides are there. We will upload the video, all the links to everything that we mentioned, all the incidents and books and what's not, everything is already there. And a very nice raffle. I think it's Amazon Echo or something for you for coming here. Go there, fill a small form, and you will get our prize within 2 days. With that, Kat, thank you very much.
Thank you.
And that was our talk.